associated with waterlogging of cotton crops. However, if a project currently being carried out at the CSIRO Canberra laboratories is successful, we could see a variety resistant to waterlogging being available in the future. Postgraduate student Tony Miller has initiated the project, and we asked him what were the objectives.
My objective has been to determine what genes in cotton are turned on when the plant gets waterlogged. So what I've been doing in cotton is to study cotton under anaerobic conditions, which mimics the waterlogging conditions, determine how many genes and what genes are switched on under these conditions, the possible identity of these genes and the role they may play in cotton. 3 of these genes encode an enzyme called alcohol dehydrogenase, which is involved in alcoholic fermentation. And this makes sense because when there's no oxygen, like when you and me, there's no oxygen, we can't breathe and we can't function. You need alternative energy sources. So this alcohol fermentation pathway, this is what the enzyme is involved in. So what we think is when there's no oxygen, the plants switch to other pathways whereby they can make their energy so they can actually survive the stress.
So what's your next step?
Well, I've actually made transgenic plants, cloning this gene in to determine if we increase the levels or decrease the levels, how that affects the plant's tolerance to waterlogging.
That's all we have time for in this edition.